Ever catch yourself daydreaming about AI writing the next, like, bestseller?
Mm-hmm.
We're diving deep into that very idea today.
Oh, cool.
Buckle up, because we're exploring cutting-edge research from the Hong Kong University of Science and Technology on long context generation
Yeah.
that's AI writing that goes way beyond a tweet.
Yeah. Yeah, it's fascinating stuff.
Like, think,
Really gets to the heart of
yeah,
whether AI can like hold a coherent thought for a whole chapter, like
right?
a whole book even. We're
Huh.
talking logic, consistency, keeping all the plot threads straight. It's a whole new ballgame.
So no more of those AI-generated short stories that just end abruptly with, and then the robot ate a sandwich.
Hopefully not. This research really pushes the boundaries. They designed a new benchmark called Get This LongGenBench,
Yeah.
specifically to test how these large language models handle long-form writing.
Long and bench, catchy. It's like
Yeah.
they knew we'd be talking about it. But seriously, what does testing long form even look like? What are they asking the AI to do?
Imagine giving an AI not just one question, but a whole slew of them at once. Like, here's 80 questions about this research paper go.
Whoa.
The AI has to generate a single response, weaving all those answers together without contradicting itself or losing the plot.
80 questions. That's intense. My brain starts to fizzle after about 5.
Exactly. It's a cognitive marathon for these AIs, and what's fascinating is that not all models handle it the same way.
But you're saying some AIs are better at long distance running than others? Tell me more.
Well, remember those big names? ChatGPT, Google's Gemini? Turns out even they get winded. GPT 3.5 Turbo, the engine behind ChatGPT, its accuracy dips almost 20% on certain tasks when things get lengthy.
A 20% dip. That's like forgetting the ending to your own story. But what about Gemini? Does it fare any better?
Here's where it gets interesting. Gemini 1.5 Flash only drops about 1% on those same tasks. It's remarkably resilient, almost like it's been training for this specific event.
Okay, color me intrigued. Why such a difference? Did they slip Gemini some secret sauce before the test?
That's what the researchers wanted to figure out. And one key factor. Size really does matter. The larger the AI model, the better it handles these longer, more complex tasks. It's like having a bigger engine in a car, more power to go the distance.
So bigger AI, bigger brain power makes sense. But it's not JST about size, right?
hmm
There's got to be more to it than that.
You're right on the money. The architecture, the actual design of the AI plays a huge role. It's like some models are natural sprinters, great for short bursts of text, while others are built for marathons.
So it's like different AI breeds, each with its own strengths. Some are built for speed, some for endurance. But how does this translate into actual writing ability? Is it just about churning out more words, or is there a difference in the quality?
That's the million-dollar question, isn't it? And this long and bench is designed to test that too. It's not just about length, it's about how well the AI maintains coherence, avoids contradictions, keeps the logic tight over those longer stretches of text.
Okay, so no more AI-generated fan fiction where the main character suddenly becomes a talking penguin in Chapter 3.
Ideally not. This benchmark is all about pushing those boundaries, and it does it by throwing a variety of challenges at these AIs, not just one type of question.
So it's like a decathlon for language models. What kind of events are we talking about?
They used three main data sets to really put these AIs through their paces. One is all about world knowledge. Think. Massive trivia challenge spanning history, science, even pop culture.
So like asking the AI to explain the infield fly rule, A and D name all 7 dwarves.
Exactly. Then there's an arithmetic data set, word problems, just like you remember from grade school. This tests the AI's problem-solving abilities, its ability to apply logic in a mathematical context.
Math and D language skills. These AIs are going for that overachiever trophy. What's the third challenge?
That would be the common sense reasoning data set. And this one is surprisingly tricky, even for AIs. It's about understanding implied meaning, navigating social situations, basically all that unspoken stuff that we humans just pick up on without even realizing it.
Ah, so like knowing that you shouldn't wear a swimsuit to a funeral, or that bringing up your ex on a first date is probably a bad idea. Those kinds of unspoken rules.
Precisely. It's one of the biggest hurdles in AI development. We humans, we learn these things through experience, social cues, but for AI, it's like trying to teach a robot to understand sarcasm. It requires a whole different level of comprehension.
Okay, so we've got world knowledge, math, common sense reasoning. It's like they designed this benchmark to test every aspect of an AI's digital brain. But all this testing, it sounds expensive. Are we talking supercomputer farms working overtime here?
You'd think so, right? But that's what's so impressive. One of LongGenBench's advantages is that it's actually more cost-effective than some older testing methods.
Wait, hold up. Did you say less expensive? That's not a phrase you hear often in the world of cutting-edge research. How's that even possible?
They actually broke down the costs in their paper, comparing it to a traditional method called NIAH, the needle-in-a-haystack test. Imagine searching for a tiny needle of information in a massive haystack of data, very resource intensive.
Okay, I can see how that would rack up the electricity bill. So how does LongGenBench compare?
They estimated that running a 128K token NIH test would cost around $40, while a similar experiment on LongGenBench comes in at about $6.60.
We're talking a difference of like a gourmet coffee versus instant coffee here. That's a pretty compelling argument for LongGenBench. But what makes it so much more efficient?
It's all in the design. LongGenBench is more focused on the generation aspect, how well the AI can actually produce text, rather than just bombarding it with massive amounts of input data. It's like the difference between cramming for a test and actually understanding the material.
So LongGenBench is like the efficient study guide for AIs,
Hmm.
helping them ace those long-form writing exams without breaking the bank.
Exactly. And speaking of acing exams, remember how we were talking about AI model size?
Right.
The bigger the model, the better it seems to handle these long context tasks.
Right, like those Quen 2 models from the research, the bigger they got, the more they just like sailed through those tests.
Precisely, yeah. That suggests that scale might be a key factor in getting even more impressive long-form writing out of AI. Imagine giving an AI not just a bigger brain, but like a whole network of brains to work with.
Okay, now you're blowing my mind. A whole network of AI brains collaborating on a novel.
Yeah.
That sounds both amazing and slightly terrifying.
Yeah. It's definitely pushing the boundaries of what we thought was possible. But hold your horses, we're not talking about like building a Skynet anytime soon.
That's good to hear. I'm not quite ready for my laptop to start writing its own sequels.
Right. Don't worry, there are still, limitations. The researchers themselves pointed out that they were working with a limited set of models and data sets. It's still early days in this research.
So the classic, more research is needed disclaimer. I feel like I hear that a lot in the science world.
It's true. But in this case, it's especially relevant because the field of AI is evolving so rapidly. New models are emerging all the time, so we need to keep refining these benchmarks, keep pushing the limits to see what's really possible.
It's like trying to draw a finish line on a racetrack where the cars are constantly getting faster and faster.
Exactly. And the researchers also acknowledged that they couldn't push the models to their absolute limits with context length because of those API constraints.
Right, like some of those GPT models had a word count limit, like a digital writer's cramp.
Yeah, yeah.
So it begs the question, what would happen if we could remove those constraints? What if we could give these AIs unlimited space to write?
Right.
Now that's a thought. It's like we're only seeing a preview of what AI is truly capable of.
And that's what makes this research so fascinating. It's not just about what AI can do today, but what it might be capable of tomorrow.
So the door is wide open for AI novelists, screenwriters, maybe even podcast hosts.
Who knows, maybe you'll have an AI co-host one day.
Hey, as long as it doesn't try to steal my catchphrases, I'm open to it.
Mm-hmm.
But until then, I think that's about all the deep diving we have time for today.
Indeed. It seems we've explored the depths of LongGenBench and come up for air.
We hope you've enjoyed this journey into the world of long context generation and the potential of AI storytelling. It's a rapidly evolving field, and who knows what amazing creations await us just around the corner. Until next time, keep those brains buzzing.